Okay, we're going to look at another example of solving a non-homogeneous linear ordinary differential equation. So notice this one, we have a sine 3t function on the right-hand side of the differential equation, which is what makes it non-homogeneous. So in the last video, we did a very similar problem. In fact, the left side of the differential equation was exactly the same. So we already did part of the problem. We already found the YH. So I'm going to just really quickly write that part down. Alright, so here we have our YH, which is the solution for the associated homogeneous differential equation, where I just replaced that sine 3t function with just the zero function, and I solved that. So then the next part that we want to work on here is finding the YP, and then our general solution is the sum of these two solutions. Alright, so for YP, we are going to use the method of undetermined coefficients. So your MyMathLab homework is separated out, so all of the undetermined coefficients problems are together, and then all of the problems that use other methods are together, so it's a little bit easier to practice. But eventually, when we get to the exam, you want to be able to choose the appropriate method for the differential equation. So I want to also talk a little bit about how you would know this would be a good choice of method. So the key is that you can find the YH first of all, so that was easy enough on this one. And then the second key is that this right-hand side function, this sine 3t function, that function and all of its derivatives form a finite list of linearly independent functions. So if you think about that sine 3t function and then its derivative, the derivative of the sine function is cosine function, so we'll get an extra 3 out front from chain rule, so we'd have 3 cosine 3t, but that's just a constant times cosine 3t, and then the derivative of that would be negative 9 times sine 3t. So we just get another constant times sine 3t. So this function and all of its derivatives are scalar multiples of either sine 3t or cosine 3t. So scalar multiples of sine 3t or cosine 3t. That is it for the list of all the possible derivative functions you get, no matter how many derivatives you take for this function. So that's when you know that this is an appropriate method. You can find YH, and that right-hand side function and all of its derivative functions form a finite list. Alright, so when you think through that right-hand side function and all of its derivatives, that tells you what you're going to use to make your guess for your YP. So I need a term in this guess for every function that comes up when I think about that right-hand side function and all of its derivatives. So I'm going to have a sine 3t term and a cosine 3t term. And the undetermined coefficients are these a and b out front, which we are going to have to eventually determine. But at this step, they are undetermined coefficients. So that's this method. This guessing method is called undetermined coefficients. All right, so the other thing to pay attention to with the guess is that you want to look at your YH solution and the functions that are in that YH, that fundamental set of solutions for your homogeneous solution. And you want to make sure that you have no duplication with the functions that are in your guess with what is in the YH. We will eventually get to some examples where we do have duplication and you have to modify your guess a little bit. So be sure to watch some of those later videos. But we don't have to worry about that for this one. So we've made a good guess here, and now we just need to take appropriate derivatives. So we need to be careful that you don't mess up these derivatives, because that can mess up everything. And I'm going to take 2 derivatives because I have a second order differential equation. So we're just taking however many derivatives I need to substitute into the differential equation. Alright, so I'm just going to substitute all of those into the original differential equation in place of the second derivative, the first derivative, and the original function. I'm going to scroll up so I have space to do that. Alright, so the first term in the original differential equation was y double prime. So I'm going to substitute in. And I'm going to go ahead and put parentheses around that just so you can kind of see as I'm writing this out here. That is my y double prime. And then the second term in the differential equation was minus 3 times y prime. So I don't want to forget that minus 3, and then times y prime. And then the last term on the left-hand side of the differential equation is minus 4 times y. And then that needs to all be equal to whatever was on the right-hand side of the differential equation. So on our original differential equation, we had sine of 3t on the right-hand side. And you can see, like, this took me 2 lines of work across my screen here to substitute in. So if your function and the derivatives are very long, or if you have a very high order differential equation, a third or fourth order differential equation, this step might be pretty long. And this is a step where a lot of students tend to make a little mistake, which then messes up kind of everything else. So you just want to be careful about negative signs and simplifying and not forgetting to substitute in for a term or something like that. So this is a place to maybe pause and make sure you substitute everything in correctly. All right, and then I want to group like terms. So you need to think about what is variable and what is a constant here. So I've got a lot of letters on the left-hand side of the differential equation. A, B, T are my letters, but some of those are constants. They're just unknown constants at this step, and some are variables. So when you think about the like terms, you want to think about that in terms of variable functions. So I've got some sine 3t terms, so I'm going to group those, and I'm going to put some parentheses out front here with all the coefficients for the sine 3t terms. So I'll have minus 9a, and I like to kind of mark them off after I've done them just to make sure I didn't forget to do any. And then in the next group here, I've got a minus 3b sine 3t, but I have this minus 3 out front. So if you tend to be a person that forgets to do some algebra here, maybe you write those little arrows like I just did to remind you to distribute that minus 3 through, or maybe you write out an extra step of algebra where you go ahead and distribute through that minus 3 and then also the minus 4 on the last parentheses here. So I'm going to just keep track of that though. So I have a minus 3 times a minus 3b, so that'll be a plus 9b. And then another sine 3t term here, and again I have to distribute through my minus 4 to both of those terms, so that'll be a minus 4a. And that's it for coefficients for my sine 3t terms. And then I've got cosine 3t terms, so I'm going to have a minus 9b. And then I'll have a minus 9a, again remembering to distribute through that minus 3. And then in my last parentheses here, I'll have a minus 4b. All right, and all of that needs to equal what I have on the right-hand side of the differential equation, the sine 3t is all I have on the right-hand side of the differential equation. So this next part is similar to what you do with partial fractions. You are often grouping like terms. So you're setting the coefficients of the like terms equal on each side of the equation. So I have the coefficient of the sine 3t is minus 9a plus 9b minus 4a, or I can combine those a terms. So I can make that minus 13a plus 9b. And that should equal the coefficient of the sine 3t term on the right-hand side, which is 1. So I'm going to have minus 13a plus 9b equals 1. And then I want to do a similar kind of thing with the cosine 3t term. So on the left-hand side of the differential equation, I've got coefficients here for the cosine 3t term. And again, I can combine some like terms and maybe write the a term first just to make my next step a little bit easier here. So I'll have minus 9a minus 13b. And then that's going to be equal to 0 because I don't have a cosine 3t term on the right-hand side. We would think of the cosine 3t term as having a coefficient of 0. All right, so you have a little system of 2 equations, 2 unknowns. And so you either solve that by hand or you use a calculator and reduce row echelon form of a matrix. So anytime you use this method of undetermined coefficients, you should end up with a unique solution to your system. If you don't, you have a mistake somewhere. Okay, so that's just kind of a good thing to keep in the back of your mind. If you get a system here that either has no solution or infinitely many solutions, there's a problem. Either you made a bad guess, you took wrong derivatives, maybe you substituted in wrong, or you set up your system of equations wrong, but that would be the time to go back and kind of look through your work. All right, so the other thing I want to say about this is that even though the original problem, I'm going to scroll back up and look at that for a second here, the original problem had fairly gentle numbers in it. 3s, 4s, some negatives, but fairly gentle numbers in it. When I solve this system, I'm going to get some fairly ugly sorts of numbers. That is normal. Sometimes students get alarmed by that and think, oh my gosh, I must have done something wrong because these numbers should come out nice. They just don't in these problems. All right, so I got A equals negative 13 over 250 from my reduced row echelon form of my matrix, and I got B is 9 over 250. And of course, my calculator spit those out in decimals, but I converted them to fractions just because it's a little cleaner sometimes to type things like that. All right, so those are my A and my B, so I'm going to put those in up here where my guess is. I've highlighted my A and my B kind of up there near the top of the screen. So that gives me my YP. Be sure you put the right number in place of the right letter. That's a really common mistake, is that students will have done all this messy work correctly and then accidentally put the wrong number as the coefficient of the wrong function. They type their answer into my math lab and it just says wrong, and they don't know if they totally don't understand what they're doing or they just made some small mistake. So just double check things like that. Did you get the right coefficients in the right place? And remember, you can send me a picture of your work and I can tell you, oh, you just put the wrong number in the wrong place, or oh no, you have a little bit more trouble, maybe you didn't make the right guess or whatever. So anyway, don't hesitate to reach out to me for some help with that. All right, at this point, I'm ready to write down my general solution for the original differential equation. So I have my YH that we found before and my YP. And so don't forget to actually find your general solution. All right, and so there we go. And if I had initial conditions, this is when I would use them to find my C1 and C2. So I didn't have that in this problem, so we are done at this point. All right, so be sure to watch the next video that has some polynomials in it, and then some later videos where you actually have to modify your guess that are a little bit more complicated.